Hi, in this video, let's discuss the 4 assumptions about areas of regions. Recall that what we're trying to do is we are looking at planar regions such as these, and to every region we would like to associate a number. So the very first assumption is that we would actually like the area of every region to be associated with a number that's greater than or equal to 0. Notice this is very similar to on the number line. If you look at a line segment, we associate a number with any line segment, and that number is really the length of the line segment, and the length is a number that's greater than or equal to 0. So here it's the same concept. To every planar region we would like to associate a number, and to us it makes sense to associate a number on the positive side, on the right hand side of the number line. So that's what the first assumption is saying. Now let's look at the second assumption. It says that the area of a unit square is 1. Recall a unit segment on the number line, that is the collection of all points between 0 and 1, and we said the length of the unit segment is 1. Very similarly here, we look at a very simple region. Just like the unit segment is a very simple segment, a very basic segment of the number line, on the plane a very simple region is a unit square. A unit square is a square whose side lengths are 1 unit. Here's a picture of a unit square. It's a square whose side lengths are 1. And we are saying, we know we want to associate a number that's greater than or equal to 0 to such a unit square. The second assumption says, let us assign 1 as the area of the unit square. And be careful to distinguish the phrase unit square from the area of a unit square. Unit square refers to this region. It's the collection of all of the points in this square. So it's a physical part of the plane. In contrast, area of a unit square is a number, and we are saying that number is 1. It's very similar to what we said about unit segment. Unit segment is a collection of all of these points. It's a physical piece. The length of a unit segment, in contrast, is a number 1. So keep these 2 assumptions in mind. Go over them carefully so they just come to you naturally, and they make complete sense that, to every region we would want to associate a number, we want to call it area, and we want that number to be a number that's greater than or equal to 0. So we want to associate to every region some point on the right hand side of 0. And one of the most basic regions of a plane is a unit square, a square whose side lengths are 1, and we are saying once and for all, let's just start with assigning a number to this particular unit square, and that number we assign is 1, and so the area of a unit square we are declaring is 1. And now let's go over the next 2 assumptions. Now on to assumption number 3 about areas. Let's read it together. If 2 regions are congruent, then the areas of the 2 regions are equal. So let me quickly review what the definition of congruence, and this is an informal definition. 2 regions are congruent if we can place one region exactly on top of the other by the following 3 moves: translation, rotation, reflection. In the future we'll be more precise and we'll say translation along a vector, rotation around a point, and reflection about a line is what we'll say. For now, let's look at some 2 planar regions. So here's one region, and here's one region, these 2 planar regions. Okay. And I claim these are congruent regions. If they are congruent, then we'll be able to say by this assumption that the areas are equal. So in other words, what this assumption is saying is, if these regions are congruent, if I can place one exactly on top of another, it makes sense to assign the same number to each of these regions. That's what this is saying. If two regions are congruent, then the areas are equal. The areas must be equal. So let me show you that these two regions are in fact congruent, that we can place this exactly on top of another. Translation means I just slide it around and I can put it, but it's not matching up. Now I see, perhaps I can reflect it about a line. So you can think of it as flipping it across. Okay. Almost there. We might have to slide it again and rotate it. So I keep sliding it and I do that and it's almost there. I rotate it and now you can see the two regions exactly lie on top of each other. And it makes sense to say somehow when we want to find a way of measuring this region, that's same as saying we want to associate a number to each region. Assumption number 3 says you must assign the numbers in such a way that the area of this first region is exactly the same as the area of this second region. So both regions get assigned to exactly the same number. That's what this is saying. Now let's discuss assumption number 4. Now here's the last assumption that we'll make about areas of regions. Recall our original goal. Given planar region, we would like to associate a number that's greater than or equal to 0 to each of the regions in a sensible manner. So this fourth assumption says we must assign a number to those regions in a way that this fourth assumption is followed. So if a region is partitioned into several non-overlapping smaller regions, then the sum of the areas of the smaller regions must equal the area of this bigger region. Notice that this assumption matches with what we know about line segments. Think of this long line segment. We associate a number to that long line segment, which we call the length. If we were to break up the long segment into three parts, then and measure out the length of each of these segments, you'll agree that the sum of the lengths of these three segments must equal the length of the longer segment. That's also the reasoning behind this assumption number 4. We would like the area assignment to be so that if we do have a big region, the number we associate with this big region and we call area, that must equal the sum of the areas of any of these smaller non-overlapping regions. So once again, if a region is partitioned into non-overlapping smaller regions, then the sum of the areas of the smaller region is equal to the area of the original big region. So we'll make that assumption. Now quickly go over all of the 4 assumptions carefully, because in the next videos I will be deriving for you areas of some special regions. We'll start with rectangles with whole number side lengths, and then move on to unit fraction side lengths, and then in general a rectangle whose side lengths are fractions, and we will see how to compute the areas of such rectangles. At that time I'll be referring to these assumptions, so make sure these assumptions are at your fingertips. Thank you.